Hello. I decided to do problem number 27 and post it on Blackboard. So here we have the problem. You can actually pause the video and read the problem first. And then I am going to do the same thing that I was doing in the class, meaning I pick a small piece on the top piece of the arc, because that is the one that is charged with the positive Q, and the one that in the third and fourth quadrants it is charged in negative Q, right? So I'm going to go with the positive first quadrant arc piece, and then here I mark the angle, that angle, the little angle, as delta or d theta, and the angle from the x-axis, positive x-axis toward the arc piece in counterclockwise direction is marked as theta. And then the length, arc length, is taken as ds. Let's call it ds. And yeah, so that's what we have. Now I'm going to follow the same things that we were doing, but before that let me actually highlight a couple of things. Here we have the charge given as 15 picocoulomb. Pico is 10 to the negative 12. And then the radius is given over here as 8.5 centimeters, and you will have to convert that into meters. So I'm not going to do all the math here. I am just going to show what you have to do in a problem like this. Now let's actually mark the electric field produced by this small piece here, and this is a positive charge, so the electric field at point E should be pointing away. And then the angle over here, this angle here, is taken as theta. So we can look at the equations now, and before that let me write the linear density of charge. Lambda equals Q over S, or L, if you want to call it S or L, it doesn't really matter. That's the length. And also lambda can be given by dq over ds, same thing. And so let's okay, before I go, what is ds? Ds is the tiny little arc piece, and that is given as r d theta. We discussed a problem like this in the class, so you know all these things at this point. And then let me write dE. Now before we go further, we understand that the x component is going to be cancelled out in this case because of the symmetricity. Because if you look at a point on this side, on the arc in the second quadrant, that will produce an electric field pointing in the other direction, equal in magnitude. And then the projection along x-axis gets cancelled out, and what is left is delta A y. I mean, the y component is the only thing that is left out. So dEy is given as dE, and in this case we can see that it is sine theta. dE sine theta. And then dE is given by k dq over r square. R is the distance from the point to the circumference. And then dq is given as lambda ds over r square. And ds is given as r d theta. So you have k lambda r d theta over r square. That's our dE. So if you want to cancel an r, you can do that, and that gives us dE equals to k lambda over r d theta. Now we can substitute it to dEy equation, the first equation over here, call it equation 1, and there you will have k lambda over r sine theta d theta. And then you can take the integration both sides, and there you have Ey, and we can take the integration from 0 to pi, and that will give us k lambda over r sine theta becomes cosine theta, and then goes from 0 to pi till negative. And then so we can substitute the limits, and you can see k lambda over r minus cosine phi minus cosine 0. So you will have Ey equals to k lambda over r, and minus cosine phi is a plus 1, minus is positive actually, because I forgot to distribute the negative sign, and there you have another one. So you have Ey equals to 2k lambda over r. Now you can go back and substitute for lambda. That will give you 2 times k times let me put the r down here, and lambda is q over pi r. We took pi r because well, actually I didn't write the pi r here. You can do that because it is only half of the circumference that we are looking at. So substitute the values that you know. 2 times, I think 8.99 times 10 to the 9. I am just writing these things with my memory, so please double check on these things. And then you have pi r square down here. We know that r also. And q is, what is q? 15 picocoulomb, and that would be 15 times 10 to the negative 12. Let me actually erase this r square. Wait. Doesn't erase. Let me see. Okay, there you go. And r, I substitute for r, which is I think 8.5 times 10 to the negative 2. 8.5 times 10 to the negative 2. And you can see that Ey, well, yeah, so that is about 2 times 15 times 8.99 divide 8.5 square pi. So I think I forgot to square this. So here you have 10 to the negative 4, and up there you have 10 to the negative 3. So you can get a value Ey 30, 2 times 15, 8.99 divided by 8.5 square times pi, and multiply that by a 10. Okay, that's what I think. You guys can check it over using the calculator. I am not using a calculator right now. Now, are we done yet? Well, we are only done with the first part, the top part of the arc. Now let me go back and look at the picture. Now we are done with the top part, right? So this is the part. Let me pick a good color and then now draw this. This is the negative q side, positive q side. Now you are going to look at the negative q side. Okay, so I am going to erase couple of things from the top, like these little parts. Okay, I'm going to leave this DE arrow, and then I am going to pick another point from the negative side. Like, let's say I pick a point like this. Now when you have a negative q, the electric field produced at the center is pointing toward, right? So you will have something like this. due to that negative arc. And then on the other side, if you pick a point like this, you will have the negative the electric field DE like that. And as you can see, the magnitude of the Q and the negative Q, I don't even have to write it like that, but I'm just doing it so that we understand that the magnitudes are equal on the top arc and the bottom arc. Now, as a result of that, the blue lines, that the blue arrows that you are looking at representing the DEs, they are also, like, by symmetricity, the x component of those electric fields cancel out and the y component is the only one that is remaining. And since everything else is the same, we can expect another term coming in due to the negative Q. Now let me actually put this as a coming from the positive side as E positive, EY positive, and then down here let me repeat the same with the negative sign to represent that it is coming from the negative side of the of the arc. And then this also should be the same exact thing because the radius is the same and the magnitude of the charge is the same and the electric fields are pointing in the same direction, right? So the final outcome of this would be double the value along the y direction. So EY net would be 2 times this. And I'm going to stop the video here so that it's not going to be too long.